Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In today's video, we are going to talk about clearance from the Shigley Mechanical Engineering Design book. Okay, so what is a clearance? In designing a general bearing for thick lubricant film, the engineer must select the grade of oil to be used together with suitable values for P, okay, for the load, for the revolution, for the R, the radius, the C, the clearance, and the L is the length of the journal. A poor selection of these or inadequate control of them during manufacture or in use may result film is too thin, or so that the oil film flow is insufficient, causing the bearings to overheat and eventually fall. Furthermore, radial currency is difficult to hold accurate during manufacture, and it may increase because of wear. What is the effect of entire range of radial clearance expected in manufacture, and what will happen to bearing performance if C its clearance increases because of wear? Most of these questions can be answered and the design optimized by plotting curve of the performance expansion and the quantities of designer has control. Okay, you can see here throughout this subchapter, you can see that if too thin is problem, if too large is also problem. You have, in the end we have to compromise. We cannot be too thin, cannot be too large. There is a reason for this. You can see. Okay, performance of a bearing. Figure 1235 shows the result contained when performance of a particular bearing is calculated for a whole range of radial clearance and is plotted with clearance as the independent variable. The bearing used for this graph is one example. In this one is example from example 12.1 to 12.4 with SAE 20 oil at inlet temperature of 100 Fahrenheit. The graph shows that if the clearance is too tight, the temperature will be too high and the minimum film thickness will be too low. Okay. Remember when we are doing the example 12.1 and 12.4, we are using the same type of oil. Okay. And temperature, high temperature may cause bearing to fail by fatigue. If the oil film is too thin, the particles may end unable to pass without scoring or may be embedded itself in the bearing. Okay, meaning that must have clearance at least the particle size of a dirt. Let's say the dirt size is the size of a normal sand, normal grain of a sand. Let's say, or smaller than that. You can find dirt anywhere in your house, okay, in your fan. This is kind of dirt, whether it can pass or not for from the clearance. If it cannot pass, it will accumulate until the end the journal will become jam. This is what we don't want. Okay, in either event there will be excessive wear and friction resulting in high temperature and possibility seizing, meaning that the journal become stuck, become jam. It cannot it cannot function. This is what we want to avoid. So this is happen if the clearance is too small. Okay, and a plot of some performance characteristic of the bearing in figure exercise 12.1 to 12.4 for ladder clearance of 0.05 until 0.003 inch. The bearing outlet temperature is designated as T2. Where is T2? Here is T2. New bearing should be designed for the shade zone. This is the shade zone. Okay, this is the shade zone. You have to design new bearing with this radial clearance because over time the clearance will be higher. Okay, they will become larger and larger and larger over time. Okay, so because of many factors, heat, okay, heat, load, and many more factors. In the end, clearance will become bigger. To investigate the problem in more detail, table 12.3 was prepared using two types of preferred running feeds that seem to be useful for general bearing design. Okay, see table 7.9. Okay, page 389. You have the textbook with you. You open to page 389. Okay, results shown in table 12.3 were obtained using equation 736 and 737 in section 78. Notice there is a slight overlap, but range of clearance for free running feet is twice the half of that close run feet. Okay, this is the table 12.3 maximum and minimum and average clearance for 1.5 inch diameter general bearing. Okay, this is type of feet, this close running, this is the symbol, and free running. Okay, okay, this is the type of feet. Let me let's say a few. This is the clearance for loose running feet, free running feet, close running feet, sliding feet. This is the transition. This is the interference. You can read the definition of it. Again, this is the symbol of it. The symbol for them. Okay. Read it. Okay. Numerical result in table 12.4. Performance in 1.5 inch diameter general bearing with various clearance. 6 clearance table 12.3 were used in with the program to obtain the numerical result in figure in table 12.4. Okay, this confirmed to the result in figure 12.5 2. Okay, so this is the numerical result. You do a programming. I'm sure you as an engineering student, you know from this subject or maybe other subject, you know how to do programming. Using Microsoft Excel also you can do programming, and there are much more software that for to help you doing programming. Okay, learn to do programming. Okay, uh, and then temperature limits for mineral oils, the lower limits for oils containing antioxidants and applies when oxygen supply is unlimited. The upper limit applies when insignificant oxygen is present. The life in shaded zone depends on the amount of oxygen and catalyst present. Okay, you see here is the temperature limit for mineral oil. Okay, temperature limit for mineral oil and everything. This is the temperature degrees up until 400 degrees. Okay, Celsius. This is the life. Okay, you can see here. And as I said, big clearance also give a problem. Small clearance also problem. Big clearance also problem. Okay, in seem that large clearance will permit that particle to pass through and will permit large flow of oil, as indicated, of course. Okay, lower the temperature, increase the life of the bearing. However, if clearance is become too large, the bearing become noisy. Logic. This is logic because the clearance is to highlight this. My marker pen is like, let's say my marker pen is the general bearing. This hole is uh, the the bushing, and then you see how big is clearance, and when it's rotate, of course it will touch like that. You can hear the voice. Okay, you can hear the sound like that. It become noisy. It become noisy, and minimum filteriness will become uh, decrease again. In these two limitations, there is a large range of clearance that will result in satisfactory bearing performance when where both reduction tolerance and future wear bearing are considered. It seems the best compromise is clearance raised slightly to the left of the top of minimum film thickness curve. Okay, you can go back to figure 12.25. See the minimum film thickness curve in future where we move the operating point to the right, increase uh, and film in decrease in operating temperature, meaning that uh, figure 12.25 show you the range you when you apply the bearing, make sure it is within the range, and then as the time goes by it will increase, and then of course you have to do the maintenance, change it regularly and everything. Okay, so that's all for this video. We see you in the next video on fragile fat bearings. Thank you very much.